Hey there kiddos, here is our quick little video over geometric sequences. Today you practiced arithmetic, today we're going to do geometric. So a geometric sequence is a sequence where you multiply by the same number to get from one term to the next. So instead of adding or subtracting like we did in arithmetic, we're going to multiply to get to the next number in a geometric. So it'll be a multiplier divide kind of thing, and instead of having a common difference, it has a common ratio. So the common ratio is the multiplier. It's what you're multiplying by to get from one term to the next in a geometric sequence. So the first thing we're going to do is just find the common ratio. We just need to know what it is. So if you look at example number 1, we know that it's geometric, so we know we have to multiply. And so to get from 3 to 9, I have to do times 3. To get from 9 to 27 is still times 3. And from 27 to 81 is times 3, and I would keep going. So in this case, R is going to be 3. So I'm multiplying by 3 to make it work. So now if you look at number 2, there are two things you should notice. Number 1, it goes 3, negative 1, 1/3, negative 1/9. And so it alternates, positive, negative, positive, negative. When that happens, that should let you know, this is going to be in my way, that the R has to be negative. Your common ratio has to be negative. It's the only way to make that alternating thing happen. So if they're all positive, then it's positive. If they're all negative, then it's positive. But if you've got an alternating positive, negative, your ratio is going to be a negative number. So now if you look at what we have here, from 3 to negative 1, I didn't really multiply by anything, because to get from 3 to negative 1, it's really a division problem. I had to divide by negative 3. Because if I do 3 divided by negative 3, that gives me negative 1. And if I go from negative 1 to positive 1/3, that is again divided by negative 3, because if I do negative 1 divided by negative 3, the negatives cancel and I'm just left with 1/3. Again here, if I go from 1/3 to negative 1/9, that's also dividing by negative 3. That's how that would work. It would make that happen. So I've got a common ratio and it looks like I'm dividing, but when I need to write down my ratio, I have to write down what was I multiplying by. So here's what you need to know. If dividing by 3 is the same thing as multiplying by 1/3. So really what I'm doing is multiplying by 1/3. And here's the easiest place to see it. From negative 1 to positive 1/3, and actually it's negative 1/3. If I do negative 1 times negative 1/3, the two negatives will make a positive, and then 1 times anything is just that same number. So that's the easiest way to see it. That's what happened. But dividing by 3 is just like multiplying by 1/3. And we're going to use the 1/3 because when it asks for the common ratio, it means what are you multiplying by, not what are we dividing by. So we are multiplying by negative 1/3. So let's practice a few more. So to find the nth term of a geometric sequence, we have this formula, and we didn't fill it. Looks different than the one you did for arithmetic because number 1 it is, and stuff's all blank. So we have to fill in our blanks. So first of all, this big square should be a multiplication sign. I don't know why it's not a dot. It came out a square and it should be a dot. So just like with arithmetic, we start with a sub n, which is our answer to whatever we're dealing with. It's the same thing as y equals. And this is our a sub 1, which if you'll remember means that's our first term. And then in here is our R, which you just learned stands for the common ratio. And then this blank is in n. It is always going to be n minus 1, and that n is the term we're looking for. That's an apostrophe. There we go. So the first couple of questions say to identify the first 4 terms given the formula for the following sequences, and then they give you a formula. Now there's a hard way and an easy way to do this. I'm going to show you the easiest way. So what I need you to do is find your calculator and pull it out really quick. So in the problem like this, when they give us the whole formula and they say a sub n is equal to 2 times 4 to the n minus 1, and I just want to find the first 4 terms, my calculator will do that for me. So if I grab my calculator and I press this button up here right under the screen that says y equals, clear out anything that is there, disappeared, I don't know why. Make sure there's nothing else in there, and we're going to enter that equation in. So here's what it says. It says 2 times 4, and that 4 is to the power of. This little button that looks like a housetop right under clear, that will make an exponent. And we're not going to use an n, we're going to use an x, but it doesn't matter. It has the same difference. We're going to do x minus 1. That's the same formula that you have on your paper, 2 times 4 to the x minus 1. Now before we do anything, you should know from up here that your first term needs to be 2. Because according to my formula up here, a sub 1 is the first term, so my first term should be 2. We're going to check and just be sure. So we're going to grab our calculator. Now that I've got it typed in, I want to press second, which is the blue button. And then I want to press graph. And you need to make sure that it starts at 0 or 1. If it doesn't, use your arrow keys to scroll so that you're there. And you can see at 1, the y value was 2. So the first term is 2. So then at 2, the second term is 8. So we grab our calculator. The second term is 8. And then we see that the third term is 32. And then we see that the fourth term is 128. So it will just spit it out for us and tell us, and we don't have to do anything. So try that same thing. We're going to use our calculator. We're going to do number 4. So you will go back to your y equals, clear what's there, and we're going to type in 4 times 1/4 to the n minus 1. So you're going to do 4 times, and to make a fraction, if you don't know this already, you press alpha, the green button, and then y equals, and you get this little menu down here. If you'll hit enter, it will make a fraction. And so you do 1, use the arrow key to the 4, and then use the right arrow key to get out of the fraction. Do your exponent to the x minus 1. And we'll go back to our table again, second, and graph. And we'll list our numbers. Okay? If you don't use the fraction in your equation, if you put 0.25 to the x minus 1, then your table is going to have decimals. Mine has fractions because I use the fraction. So the first term, which we should know from looking at our formula, is 4. The next term is 1. The next term is 1/4, and then the one after that is 1/16. So I have 1/4 and 1/16. So that's how we use our calculator to fill that in. If you didn't want to use your calculator, you were going to need it anyway, because you're going to have to plug in values for n and then do the calculations. Just have it tell you what they're going to be. So let's look at a few more. 5 and 6 ask for the formula for the nth term, which, if you remember, means we want that explicit equation. So we want to plug in and we want to leave n as part of our equation. The first thing we need to do is identify some stuff. So a sub 1 is our first term, which in number 5 is a 3. The common ratio that we are looking for, we did this one a minute ago. It's the one we found the common ratio for at the beginning, is times 3. So the r is 3. And the a sub n is what we're getting ready to find. So we're going to do a sub n is equal to, and we're using this formula from right here. It's a little simpler than yesterday, but not so much. A sub 1 is 3 times, the common ratio is 3 to the n minus 1. You can put it parentheses or you can leave it out of parentheses. It doesn't make a difference. I put it in parentheses so that I remember that all of that needs to go together. That's it. So this is what should go in that blank for a sub n. This is going to be your explicit formula for the geometric sequence to find any term. We do not multiply this 3 times this 3 because this second 3 has an exponent attached to it, so they can't go together. We just leave it alone. So let's do number 6. A sub 1, the first term is 3. We did this common ratio a minute ago as well, and we found out that it was -1/3. We used the fraction because it was dividing by 3. They were getting smaller. Anytime the numbers decrease, you will have a fraction for your ratio instead of a whole number. And so our a sub n is going to be our first term times our ratio, -1/3, to the n minus 1. So that's what should go on that line. That's your expression for the nth term. So let's look at 7 and 8. The first term of a geometric sequence is 256. So this is a sub 1. The common ratio, r, is 0.5. We want a formula for the nth term. So we have a sub n is equal to 256 times 0.5 to the n minus 1. And so to find the 10th term, you have two choices. You can do 256 times 0.5 to the 10 minus 1, and you can put that in your calculator, or you put this whole equation in your calculator and go find 10. So we're going to go to our calculator. We'll go back to y equals, and we'll enter 256 times 0.5 to the x minus 1. And then we go to our table, second graph, and we want the 10th term, so all the way down here to number 10, and we see that it is 0.5. And so the 10th term of our sequence is 0.5. That is your answer. So that's geometric sequences. That's how we use it. We will practice this when you come in tomorrow. You guys have a good rest of your day.